We will now move over to talk a little bit about the database. Most of our applications will be needing some type of backend database where we will be storing and retrieving data. In this example, I'll be creating a POS, a point of sale application from scratch. So I'll start off with the database and explaining how the database is being mapped and accessed with Studio. So I'm gonna start out something with very basic entities. So entities, we're gonna be selling products. So like bagels, donuts, ice cream, drinks. So I'll have a list of those things. And when I sell those things, I have to give a receipt to the client. So in order to sell something, I have to print out some type of receipt. So I'll have a list of receipts. Now, here's a very interesting thing. Products and receipts have a relationship between them. One product can be sold in many receipts, and one receipt can contain many products. So, because we have a many to many relationship, we need to do a bridge entity, and we'll call this bridge entity product lines. So, we'll have a list, a separate list that will contain the products, and they'll tell me to which receipts they belong to. And the final entity we're going to be talking about is a simple list of clients. Like if we keep track of who we are selling things to, so we'll have their ID, their name, and any information that is related to a client. So I'm keeping this as simple as possible. I'm just going to be using four tables or entities to describe this database. I'm pretty sure that in your applications you might have dozens or more. This is the ERD diagram that we'll be using. This is the product. You can see I have the ID product, the name, price. This is the list, the bridge entity that is describing the many-to-many relationship. All it has is the foreign key for the receipt, the foreign key for the product. I'm also describing here the quantity and the price of each item when it was sold. The list of receipts, all it has is the total cost and what date the receipt was printed. And finally, the client, we just have first name, last name, date of birth, and the gender. So it's very simple and straightforward. So I moved over to Navicat. This is a very easy tool to use to design databases. If I were to create a new table or do anything over here, I can just click on this, but I already done this to save a little bit of time. So I'm going to right click and open. So here's an example of the records I'm going to be using for this demo. This is my primary key, the name, and the price of each of the items I'll be selling. This is the foreign key of the receipt, the foreign key of the product. So receipt number 2, sold product 1, and product 3. And I can also really easily take a look at what products are what. So 3 is a hamburger. So 3 hamburger and a donut. So receipt 2, sold the hamburger and a donut. And this is the quantities of each and the unit price of each. I'll go over to the receipt. So this was sold to client number 1 and 2, total cost of the receipt and the transaction date. And finally, client is very straightforward. First name, last name, date of birth, and gender. So I have a list in the primary keys, which I wire everything up using foreign keys. So you can see how nice and visual Navicat presents this database. I can hover over here and I can see the link of the foreign key and the primary keys. So it's a really good product. I really recommend you guys can use it. Like you can use it for a 30-day free trial. Now that we have a really quick view on how the database is structured and my MariaDB or MySQL, they're both interchangeable. We're gonna go over and talk a little bit about how Studio works with this. So we already covered that Studio and all these applications use services to communicate between the client and the server. So the database is also a service. And the server is running Java code. All it knows about is Java classes, Java code, object-oriented objects, and all that. So this is Java is a very good programming language. And on the other side, we have MariaDB or MySQL, which is a very good standalone SQL database. So I want to point out that these two are different software packages, and each of them are independent of one another. So here we're talking Java or object-oriented code, and here we're talking about structured query language or SQL. So there has to be some way to communicate one with the other, and this is where tools like object relational mapping kick in order to bring these two together and make it easier to communicate these two independent software packages. So that's where Hibernate comes in. Hibernate is a widely used object relational mapping, and it's widely used in Studio. That's what makes it so easy to create, insert, and update records within Studio. So what is Hibernate? Hibernate's just the mapping of the tables of the database into Java classes, and it uses some type of XML mapping in order to configure and how these Java objects or these plain old Java objects are going to be used in Studio. So it's easier to demonstrate than talk about it. So I'm gonna create a service, and then we'll see exactly where it's located. So just give me a quick second. I'm gonna be doing a new project. I'm gonna call it app sales, and I'm going to services import database. We're using my SQL here. The host is going to be localhost. Username is going to be root. I don't have any password in this one. It's a local test server, and I'm going to be calling this sales. So if I do test connection, I can connect to it, and then I'm going to import it. So now that I have a successful import in the services panel, now I have a services database right here. And if I expand this, you can see that all my entities from the database are now mapped as Java objects in here. And there's a sample query that is auto-generated, but we don't have to worry about that now. But this is interesting. If I expand here, I can see that I can see the ID. It's detected as a primary key, first name, last name, date of birth, gender. And there is a relationship between the receipts. It's one to many. One client can receive or be sold many receipts, and I can see that the directionality of how this entity is pointing to the other one. And I'm pretty sure older WaveMaker or older Studio users have been able to do very fast user interfaces using the database widgets, because these are very nicely packed things, because they do all the widgets we need to do. So let's create a client in here. So I just drag and drop the database widgets that pop up after I create my database service. I will click on my grid here, this second one. This drag and drop functionality is great, and what it does, when you click and drag this database widget, it goes in here into the model, and it creates all of these widgets like the dialog box, all of the fields in here, a form object, which is the one that is in charge of doing the insert, update, and delete operations, and a grid, which pretty much does the read operation on the service. And in order to get information, the grid, if we take a look here at the data set, we can see we have a client live variable. Now, client live variable, we'll have to go over here to the services, and these components down here are the ones that make the service calls. So if we take a look at the client live variable, we'll be seeing that it's going to be calling this object right here on the sales DB. It's going to be calling the client class, and this client class is the one we saw previously on the Java, and it's just going to read data. Here we can put maximum 500 records, and it's going to automatically load. As soon as we run Studio, it's going to automatically be fired. So this is what gives us the data onto this grid. So the live variable is the data source for this grid. Now when we click an item, this selected item of the grid becomes the data source for the form. Now the form is the guy that saves that saved the data last time. So if we go into the form here and we look at its data set, we're going to see the client dojo grid selected item. So number 2, Jane Joan, is the data that is being fed into this. So here I would like to talk a little bit about how this is structured. So the live variables will call a read service, and all the services are wired up into this framework called Spring. It's becoming the most popular framework for doing this type of thing in Java. So all the services are saved into this Spring. Now Spring is also configured to work with Hibernate, and Hibernate is the guy that's going to be translating all this data coming in and out into the database. So live variables will do a service call and just get read. All this is going to be translated down. This is going to on the fly create compatible SQL code for MariaDB. Then MariaDB will give a result. It'll translate that into usable Java objects, and Spring is going to do some type of conversion to throw that back into a JSON object, which is what we see in the browser. We don't see a Java object, but we see a JSON object. So all this translation is going on between these components to make it easier for us to work with it. And the form also by itself is going to do an insert service, and it's also going to throw it over to Spring, and Spring is also going to do the same, and it's going to be forwarding over to Hibernate. Hibernate is going to translate that into an insert statement on SQL, and SQL is going to return probably the last inserted ID, and then that's going to be translated into a JSON object. The JSON object is going to be returned into the form, and then you'll be able to see that in your browser. And now I'm ready to create records. It's that easy. So let's just make a new client in here. So I'll just press run. Okay, so I'll go over to this. This is going to be our end product, but eventually we'll get here. All right, so I'm presented with my grid. My records are already being loaded from the database. If we take a look at Firebug here, we can see that it's doing all these GET requests to download all the required JavaScript files for the browser to run, and I'm getting a post request here, and it's just posting. It wants to read the client, and the response is the JSON object, which is loading this, whatever is being fed into the grid. And this is essentially these records on the database. Another thing that's very important, which I've seen in the forum, is that some users are not careful loading and limiting the max records, because you can see here max results 500. If this table had 1,000,000 records and I don't have this 500, I'm gonna overload the user's browser. So if you guys have any problem with your application running slow or something like that, this is a really good place to check. You have to be limiting the amount of data that you're loading from the database and loading into the user's browser. So I'll be covering a little bit more of this in detail further down the road, but I'd be really like to, if you guys give me some feedback on how this is going. So I'm gonna clear my console because I want to just insert a quick record. I'm gonna click on new. Jake Mullins, date of birth 1987, gender M. Okay, now here's a little bug on the Studio side. Typically when you get a date widget, Studio has an issue figuring out if it's a date or a timestamp. So let's fix this real quickly here. I wasn't counting on that, but right now it's a date. The database here has it as a date object. It doesn't have any time with it. But when you import the widget, it thinks it's a date time. So all we have to do is just change the editor. It's a little nuisance. So I make sure it's a date object right here. Oops. You can see here it says date, and it's now receiving on date. So let's run this again. it won't let me save because of that. So let's run this up again. All right, we're seeing the post. Oh, another good thing to notice, you can see how long it took to do this. So it's really helpful to take a look at this if your application is slow. So let's try again. Jake Mullins. Now let's put a date. Now it's just gonna be a date. And it's not gonna wait for this timestamp. So the form is now valid, and now I can perfectly save the record. Now I saved Jake. It does a post request. This is when it reloaded the grid. This is the post request. That's gonna do an insert, and here is the object I'm sending here. Date of birth, first name Jake, gender male, ID client is 0 because the database will decide what ID it's gonna do. It's gonna give us, and it's gonna be last name Mullins. So now, like if it were magic, if I refresh my table on my database, I can see Jake Mullins was successfully saved and stored into the database. Now we successfully loaded data from the database, and we successfully stored data into the database using service calls, using post requests. Now, how does Hibernate work behind the scenes? We'll take a look at these Java classes and these XML mapping files. And to get to them, we just have to go to our projects folder. This is my current path for my projects folder, but I'm pretty sure you guys can find yours. And my application is called App Sales. So in the root of my application, I have a folder called Services. And in Services, good enough, when I imported my database, I have the Sales DB service right here. So if I go to source, com, Sales DB, data, these are the Java classes I'm talking about that Hibernate creates using the mapping of the database in order to allow Java to run queries and work with the database a little bit easier. So let's take an example with client.java. So you guys that don't have experience with object-oriented programming, don't worry about it. We don't have to go much into detail with this, but this is a plain Java object. It has the object is called the client, and we can see the fields, the ID client, first name, last name, date of birth, gender, and the directional reference to the receipts, which are the foreign key that's related of one client has many receipts. It's also described in here. So this is very similar to what we have on our database. So if you go to a database and compare, we can see here these are our this is an integer, these are varchars, this is a date field, and this is a single char, I believe. So the mapping here makes Java work with this mapping directly. It doesn't have to be doing any translation or moving columns whenever we do a query. This is so convenient. We have this tool because it makes querying and running things in the database between Java and pretty much any database package very easily. So if I also go here to our data, we also have this XML mapping, which helps us with the configuration of exposing that class into the service. So we have here the class name and what table it goes to on the database, and all these other properties and information that Hibernate utilizes it to help build the service. So it's not 100% critical. You guys learn about this, but it's really good to have the background about how things are working, because when we go further down and we do criteria queries, knowing about these objects is going to be really interesting. Now it's good I mentioned criteria queries because I want to talk a little bit about querying before I end this little module. So querying, whenever we're using MariaDB or Oracle or Postgre, anything, we're going to be using SQL, and SQL has been there for many years. It's widely known, but Hibernate it's going to be using one of two things. Uh, Hibernate query language, that's what HQL means. It is a query that is run on top of the Java class object. So when you run SQL, you're running the query directly onto a database because it's natively supported by the database engine. But when you run Hibernate, your queries are actually being run on top of these Java files, on top of these Java classes. So it's another layer on top of it, makes it very easy to do queries, and you don't really have to care much about what data package you're using, what database package you're using, because your queries are being run on top of these objects here. And criteria is a class you can use to elegantly make select statements. It's very nice. It's very good. It's um, a little advanced for now, but I just would like you guys to know how that it's there. We're definitely gonna go there further down the road. We have to build some Java code in order to actually demonstrate these two. So I hope it's helpful. Please give me your comments on the video or on the forum. Further down, we're going to be talking now about making a nice UI for our application. Now that I just gave a little bit of background on the database, so I hope you enjoyed it.